In this video we're going to talk about combining like terms, and we'll get to an official definition of what a term is here in a minute. But for right now, let's just start off by reviewing what a variable is. A variable is a letter that's used to represent an unknown value. And hopefully you've seen this before. And we're going to bring in some fruit to help us make the point about like terms. So let's go ahead and define a variable A. And that A is going to represent the cost of one apple. So we don't know what the cost is. And we're going to write an expression to represent the cost of a certain amount of apples. So for example, let's bring in some fruit to help us out here. There we go. We have 3 apples. So if A is the cost of 1 apple, how much would these 3 apples cost? Well, hopefully you said 3A. 3 times the cost of 1 apple would give us the cost of these 3 apples. So that's just an expression to represent the cost of the apples. Alright, let's go ahead and bring in some more apples. That was so much fun. Let's bring in some more apples here. Okay, so how many apples do we have there? 1, 2, 3, 4, 5, 6, 7. So how much would those apples cost? If each apple cost $8, then those apples would cost 7 times A, 7 times the cost of 1 apple. So the idea of combining like terms, this 3A represents a term and this 7A represents a term. So if we wanted to buy both of these things and we wanted to know the cost of all the apples together, we could add that together. We'd say, well, 3 apples, the cost of 3 apples plus the cost of 7 apples would give us, hopefully you're thinking, 10 apples, 10A, 10 times the cost of 1 apple because I have 10 apples. That is the basic idea of combining like terms. Now these two terms are like terms because they both represent apples. Let's say we throw another variable in the mix here and we let L equal the cost of 1 lemon. Alright, and now I'm going to bring in some lemons. So, how much would those lemons cost? We got 3 lemons, and each lemon cost L, whatever that is in dollars or cents. So the cost of those 3 lemons would be 3L. 3 times the cost of 1 lemon. Now let's say I wanted to buy all this. Okay, I want to buy this, plus I want to buy this, plus I want to buy this. So if I add all these together, that would be the total cost of buying all this fruit, these 10 apples and these 3 lemons. A for the cost of an apple, L for the cost of a lemon. So what's the cost of all of it together? Well, we know these apples, they all cost the same, so that would be 10A for those 10 apples. The lemons are just going to be 3L. So I can't combine that with my A. That's as good as I can do right there is another way to say it. That's as simple as I can write that. How much will all this fruit cost? 10 times A plus 3 times L. The idea of a like term is that the variables are the same. The 10A represents a term and the 3L represents a term. They are not like terms because one has an A and one has an L. And I think visualizing that this A stands for something like the cost of an apple and the L stands for something like the cost of a lemon really helps you to see why you can't combine those together. It makes perfect sense. It's not going to be 13 times anything because the cost of the apple is different than the cost of the lemon. Alright, let's look at a different example and see if we can write an expression. Let's get rid of all this. And I got one more type of fruit here, so I'm going to go ahead and define P to be the cost of 1 peach. Oh, I got rid of all my apples and peaches. Okay, so let's, I should have just moved them. That's okay. I got some more fruit over here. So let's do this. And we'll bring in some of these. And we'll bring in some of these. And we want to write an expression for the cost of all this fruit. The most simplified expression we can write. So these guys over here, we got 3 peaches. They kind of look like nectarines, but they're peaches. So I got 3 peaches over here, so that is 3 times p times the cost of 1 peach plus 1, 2, 3, 4, 5.5. Let's say we got 5.5 lemons. 5.5 or 5.5 lemons plus 1, 2, 3, 4, 5, 6 peaches, so 6p. So I've got 3 terms, but I can combine 2 of those together because they are both p's. The 3p and the 6p is going to end up combining to be 9p, and then I just bring down the 5.5 L. And that is as simple as I could write as an expression for the cost of all this fruit. Alright, let's try one that doesn't have any fruit. Let's see. Let me move this stuff over here just in case I want to use it again. I won't lose it. And let's put this A, L, and P off to the side for a minute. We might use this again, but let's just forget about that for a second. And let's say you get a problem and you're asked to simplify 3x plus 2y minus x plus 8y. So first thing is, we don't know what these x's and y's represent, and they're not always going to tell you that. It's just going to say simplify, and it's going to give you a bunch of stuff like that. So what you want to first determine is how many terms there are. The terms are separated by the pluses and minuses. So 3x is a term, positive 2y is a term, and also the sign in front of this number is the one that's assigned to it. That's why there's a positive 2y. Then I think of this as a negative x or a minus 1x, and this is a positive 8y. Now the reason I say negative, even though it looks like a minus, there's a couple things going on with this term right here. It's the negative and also the fact there's no number in front of there. So let's talk about the number first, and then we'll come back to the minus sign or the negative. When there's nothing written here, you can always think of it as a 1. Because 1 times x is just x. So this does represent 1x right here. Now as far as the minus or the negative goes, it is written as a minus, but hopefully you remember a rule from subtraction that subtracting is the same as adding a negative. So for example, if I had 6 minus 8, that's the same as 6 plus negative 8, which is negative 2. So in other words, minus a 8 is the same as plus a negative 8. So when I see a minus a 1 here, I could also think of it as a plus a negative 1 if I wanted to. Alright, so I have 4 terms. I've got 3x is a term, positive 2y is a term, negative 1x is a term, and 8y is a term. And I want to ask myself if I have any like terms. The like terms are the ones that have the same variables. So the 3x and the negative 1x are considered like terms. X might represent the cost of something, and that's, we're buying the same item there. And the 2y and the 8y are like terms because they both have y's. So what we can do is we can combine those together. You don't have to do this next step I'm going to write down, but you might want to. You could rearrange these as negative 3x minus 1x plus 2y plus 8y, putting the like terms next to each other. You don't have to do that, but you can, and that's the commutative property. Says you can change the order that you're adding things, and it's okay. You know, 5 plus 6 is the same as 6 plus 5, so we can move that stuff around. So 3x take away 1x would be 2x. This is the actual combining of the like terms here. 3x take away 1x is 2x. And 2y plus 8y is 10y. Now I have x's and y's like apples and lemons. I can't combine these together. These are not like terms. So this is as much as I can simplify on that problem right there. That's as far as I can go. And like I said earlier, you don't have to write this middle step right here. You could actually just go 3x, take away 1x is 2x, and 2y plus 8y is 10y. Usually when we're writing these, we write the terms in alphabetical order by their variables. We'll put the x term first and then the y term. Let's look at another one that's got more than two variables in it, because it's possible to have all kinds of variables. We could have apples and peaches and lemons and oranges and all kinds of fruit. So let's say we've got, let's use this color. Let's say we've got 5r plus 7t plus 6r minus 4s plus 8t. That's good. Okay, so I got 5 terms there. 5r, 7t, 6r, negative 4s, and positive 8t. So we want to find the like terms. 7t and 8t are like terms, and 5r and 6r are like terms, and minus 4s doesn't, it's a term, but there's no other terms that are s's, so there's nothing we can combine it with for our next steps. Let's go alphabetical order. I guess first would be r. So 5r plus 6r is 11r. Next would be s, so we got minus 4s, and there's nothing to combine that with, so I just bring it down. And then 7t plus 8t would be 15t. And that's as much as I can do. I can't combine those together because I got r's and s's and t's. Now sometimes you'll have problems where you'll just have a number that doesn't have any variables that it's being multiplied by. For example, you could have 5x minus 3y. Let's try some ones with some more difficult negatives here in here. Minus 10x minus 13 minus 7y plus 4. So now I've got 6 terms. 5x is a term, and that can be combined with the negative 10x. That's another term. Remember, the minus goes with the 10, so you think of that as like a negative 10. So we're going to end up doing 5 subtract 10. This minus sign goes with this 3. Okay, so now for the y's, we've got negative 3y and negative 7y, or minus 7y. Either way you want to think about it. I know I'm saying it both ways, but that's because you might be thinking of it one way, and you can either think of it as a minus 7y or a negative 7y, whatever makes you happy. And then we've got negative 13 and the positive 4. So in this example, unlike other examples, we have terms. The negative 13 is actually a term, even though it doesn't have a variable on it. What you have to remember is that the terms are separated by the pluses and minuses. So I'm going to do this in yellow. It's going to be kind of faint, but you can, oops, that was, let's, okay. So 5x, bam, minus 3y, negative 10x, minus 13, minus 7y, plus 4. So those are your terms. Every time you see a plus or a minus sign, that's the signal that there's a new term. So that's how I'm getting my terms, my 6 terms. So even though this negative 13, this minus 13 here, and this positive 4 don't have variables on them, they're still terms, and they can only be combined with other terms that don't have any variables. We call those constant terms. I'll just write that down here. Those are called constant terms. Constant means it doesn't change. Variable means changing. So that kind of makes sense. These terms aren't going to change because the values of x and y might affect the value of this. If x is 1, this term is going to be negative 10. If x is 2, this term is going to be negative 20. If x is 3, this term is going to be negative 30. Whereas the 4, no matter, it's constant. Nothing's going to change it. If x is, whatever x or y is, isn't going to change this term. It's constant. That means it doesn't change. Alright, so hopefully you got an idea about what I'm going to write on the next step. You might want to pause the video and see if you can get this one, and then start it again when you have your answer. Alright, let's see what you got. So 5x take away 10x is negative 5x. Negative 3y take away 7y, or negative 3y plus a negative 7y, any way you slice it, is a negative 10y. Now you could write that as plus a negative 10y, but the way you'll probably see it is a minus 10y. So if the 10 comes out to be negative, just write minus 10y. It's the same thing. Then we've got negative 13 plus 4, which is negative 9. Again, I could write this as plus a negative 9. I could write it like this, plus a negative 9. But the way you're probably going to see it, because it's a little more concise, is to just write minus 9. Now I can't combine those together. I am done. Here's the biggest mistake I see. I'm going to write it in red just to say this is wrong. People will take the negative 5 and the negative 10 and the negative 9 and put all those together. Add all those up. Negative 5 plus negative 10 is negative 15, plus negative 9 is negative 24, and they'll write something like negative 24xy and call that their answer. That is not, and we don't want that. Think back to the apples and oranges. I know it's a little weird with the negatives in here, but x is representing something and y is representing something totally different. So you can't combine those together and say that it's x times y. So that's the idea of combining like terms. The big thing to remember is you can only combine terms that have the same variables in them, and keep these in mind when you're working with those. Keep those apples and oranges and peaches in mind, that they're representing, those variables are representing something in the real world, and that's why you can combine them together. I hope that helped.